particular compound proposition. Okay. So once again, let's do our substitutions. Where we see P's, we're going to put in F's. Where we see Q's, we're going to put in T's. And where we see R's, we're going to also put in T's. So this now becomes, the R's go to T's, so this becomes true, ORed with false, which needs to be negated, which all needs to be negated, okay? Which needs to be ANDed with P is false, so false needs to be negated, which implies Q is true, which needs to be negated, ORed with, well, Q is true, okay? So now let's just do all of our negations really quickly. So this becomes T ORed with true, because the false goes to true, needs to be negated, ANDed with this false goes to true, which needs to imply this true goes to false when we negate it, ORed with true. Okay. Now we can do this OR here, and we can do this OR here. So this now becomes T ORed with T is going to be T, which needs to be negated, which needs to be ANDed with. Okay, over here now we have T implies, well, F ORed with T is also T. Okay. So nearly there. Before we do the AND, we have to do the implication over here, but we also need to do the negation. So this goes to F, ANDed with, well, T implies T, true implies true. You can see in the implication that that's always true, so this goes to true. And finally we have F ANDed with true, F ANDed with true. We have an AND here, so we have an F ANDed with true is always going to be false. So this actually this evaluates this whole proposition now. Okay, this evaluates down to being false. Okay, this is false. This is what this evaluates to. Okay. And I mean, we could make these propositions up all day long, okay? But the point behind it is that all we're going to do is, when we want to evaluate it under a particular state, is we take the truth values, okay, and we substitute them into the actual proposition. So, like, if we change the truth values, okay, let's say on the first one here, okay, let's say for argument's sake that instead of having P false, let's say we had P is true. Let's say Q is also remains true, and let's say for argument's sake, well, let's say let's say OR then goes to false. Okay, so let's say OR goes to false, OR goes to false. The question is, what does this proposition P ANDed with Q bar implies P bar ANDed with OR? What does it evaluate to? So do our substitutions. Okay, so we do our substitutions. This becomes true ANDed with true bar implies true bar ANDed with false. So this here becomes true ANDed with false implies this becomes false ANDed with false. Okay, true ANDed with false. Well, we know from our AND that the conjunction, the AND, true ANDed with false is false. So this becomes false implies, and similarly over here, false ANDed with false is false. And then the implication, well, the implication is actually true. So when false implies false, the implication actually evaluates to true. So what we have here is, what we're really showing is just another let's say reduction, okay, of this particular compound proposition under this particular state here. Let's keep in mind that we could evaluate it under many states, okay? And to do that, we typically construct our truth table, and in our truth table we list our propositions. So they're P, Q, and OR. We could have, let's say, false, 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 true, false, true, false, false, true, true. And then we have true, false, false, true, false, true, true, sorry, true, true, false, and true, true, true. Now what I'm really trying to get, I'm not going to do this evaluation, you can look at one of my previous videos, is that this particular, when P is true, Q is true, and F is false, so we have true, true, false, so we have true, true, false. It was this particular state here that we evaluated this proposition P ANDed with Q bar implies P bar ANDed with OR. Okay, it was this particular state, and what we actually evaluated it to was a true value. And earlier, under the different state, false, true, true. So false, true, true is here. What we did was we evaluated this statement also to be true. the point I'm trying to make here is this: is that from a truth table, we evaluate the proposition under all possibilities, with all possible, let's say, pairings of inputs, okay, of states, okay. But when we're just we can also just evaluate the proposition just from a single set of truth values, if that makes sense. And the way we do it is just based off our basic algebra. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope that this video dealing with propositional logic, I hope that was in some way intuitive. And more importantly, I hope that was helpful for you. Thanks for watching. Okay, bye-bye.